We are solving number 76 on LeetCode, minimum window substring, which is today's daily problem. It's a classic two-pointer sliding window problem, and the techniques I'm about to show you can be used in so many different contests and tech interview questions. So open up your browser and code along with me. This is Alex Does LeetCode. Like and subscribe. Let's start by looking at the problem. You're given two strings S and T, and you're supposed to return the minimum window substrings of S, such that every character in T, including duplicates, is included in the window. If there's no such substring, return the empty string. Example 1. Let's say S is this, Adobe Code Bank, okay? And T is A, B, and C. Well, what are the window substrings that contain A, B, and C? This one is a substring that contains A, B, and C. There's A, there's B, there's C. The whole string, the whole of S, is also a substring that contains A, B, and C. It's got A in it, it's got some B and some C. And so is this one. But among all these valid windows, the smallest substring you can find is bank, B-A-N-C. This is only 4 characters long compared to this one, which is 6 characters long. So the answer here is bank. So first, find if the substring with the window substring is valid. Second, we want to find the smallest, the shortest one. Here's another example. Let's say S is A and T is AA. Now, this is where the part about duplicates come in. You might think that, that since there's only A's in T, this is a valid substring, but it turns out it's not. Because there are 2 A's in T, you also need 2 A's in the substring window for it to be valid. There is no substring in S that contains 2A. So this is basically impossible, and we want to return the empty string. Now, the fact that the word window features so prominently in the problem description suggests to you that probably you want to use some kind of sliding window technique. This is a very general technique that's used all over the place, even in real production code. So pay attention now. Let's first go through the intuition for how we might want to do this. Let's start by doing some preparatory steps. The first thing we notice is that T is in a very unwieldy format. It's a string. And since there's no way to tell easily what letters are in a string and how many times will occur, we want to transform T into something that's slightly easier to work with. Specifically, I'm talking about a dictionary, a frequency dictionary. So here in this dictionary or hash table, you can see that A appears once, B appears once, and C appears once. We have all the letters that appear. They're easy to search, and we know how many times they appear. And this is so much easier to work with than A, B, and C. Next, we want to create a window over a substring of the string S. And it looks something like this. The standard way to represent this window is by the start and the end pointers, hence the name two-pointer sliding window. We want to keep track of the letters inside this window and how many times they appear. And we're going to use a hash table, just like we did for T. In this example, A appears once, B appears once, and C appears once. Note that letters that do not appear in D are never recorded. We start by initializing our sliding window to just the first character of string S. And it's going to look something like this. In this window, A appears once, but B and C never appears. The next step is to move the right pointer one letter down. Well, we don't see this. Well, this new letter doesn't appear in T at all, so we're going to skip that. We're going to keep moving, and we're going to keep going until we reach a letter that appears in T. For instance, this B over here. In which case, what we'll do is to update the number of characters in our current window. And we'll keep going some more until we reach a point where this window contains all the letters found in T, including duplicates. And we know this by comparing the counts in our current window to the counts in the original frequency table associated with T. So you can see that all these counts are the same. And so this sliding window is valid, but it's not the smallest sliding window we can find. In fact, what we want to do is then keep going with the original right pointer. We keep going, we keep going, we keep going until it reaches something like A. So what happens when we reach A? At the point where we reach A, there are now 2 occurrences of B and 2 occurrences of A. Then we notice something. Hey, there's 2 occurrences of A. Maybe I can ditch the first A. Right? So you notice that A is sort of, we're overcapped on A. So we can actually move the left pointer and ditch the first A. Where do we move the left pointer to? Well, we keep going. We keep going. Do we move the left pointer here? No, because D is not a letter that appears in T at all. We keep going until we reach a letter that appears in T. And now we notice that, hey, you know what? B also appears twice in the window. B is also overcapped in the window. So we get to keep moving again. And we keep going until we reach here. Now C only appears once. And this occurrence of C over here is necessary to keep our window valid. So we can't move the left pointer anymore. So we record the best length that we see here, which is 1, 2, 3, 4, 5, 6. So 6, the last one we had was 1, 2, 3, 4, 5, 6. It's also 6. Well, not that great. Okay, so the best score we've seen so far is still 6. Now we go back to moving the right pointer. We see an N. Well, keep going. And now we see a C. What happens when we see a C? Well, C goes to 2. Now we're overcapped on C and we can move the left pointer again. So notice every time we see a new letter, in T and we realize that we're sort of overcapped on that letter, we can start moving it. We can start moving the left pointer. And in this case, we're going to keep going all the way. It's going to end up somewhere here, which gives us a window BANC, which is of length 4, and this is our correct answer. This technique also works if there are multiple occurrences of the same letter in T. So let's say, for instance, we want 2 B's, right? So B is 2. So we start from A, we keep going. Well, we have a B. So B is 1. There's still no C's in this. And then we keep going again. We have a C and then we have a B. So at this point, we have 2 B's and 1 C. And what do we notice here? We notice here that we, unlike in the previous situation, we're not overcapped on B. We need 2 B's and we have exactly 2 B's. And our score here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's score 10. It's not a great score. Okay? So what happens we move one more? Well, we see an A. That's great because now we're overcapped on A. We can start moving the left pointer. Where can the left pointer move to? We keep going. We don't need this A anymore. We don't need D, O. They don't appear. Do we need this B? Yes. It turns out we do need this B. So we can't move anymore. So we're stuck. This is another right answer. 1, 2, 3, 4, 5, 6, 7, 8. So score of 8 is slightly better than just now. Right? And then now we keep moving. Okay? None of these produce a score better than 8. So we stop here. The first thing we want to do is to turn T into some kind of frequency dictionary. So we count the frequency of each character in T. Next, we want to initialize some default values. Best is the best window that we've seen so far. At the beginning, best is just 0 to infinity, is the length of the entire world. Current is another dictionary. This would keep track of the frequency of characters seen in the current window. And previous, I'm going to actually make this a deck, and I'll show you what I'm doing. So previous is our left pointer. Let me name it left instead. So left is a left pointer. And I'm going to make this a deck because we're going to make it jump a little bit faster. And finally, we have this thing called unfinished. So unfinished keeps track of how many rows, how many letters are still not capped yet. At the beginning, when A, B, and C are all 0, unfinished equals to 3. So as the letters start getting capped out, so let's say A is capped out, 2, B is capped out, then unfinished will go down. It's going to go down instead of 3. It's going to go down to 2. And it's going to go down again, in this case, to 1. Because we know that A is capped out, B is capped out. We have the required number of A's and B's. Only thing is not C. C is not. So that's why unfinished is 1. Because there's one letter that where we've not met the minimum requirement inside the window. The next thing we're going to do is to slide the window. This is the moment we've been waiting for, boys and girls. So for right, in range, length of S. So right is the right-hand side of our window. So using left and right, we're able to keep track of the sliding window. So new character equals to S right. This is a brand new character we're adding. If C is not in freaks, we continue. Else prev.append. Right. Now, this is kind of a weird thing. I'm setting this up, and I'm going to show you why this is important later. So, current C plus equals to 1. Okay, so here we are incrementing our window. So we're adding C to the current window. So if current C equals to freaks C, so we are going to check unfinished minus equals 1. As long as as long as unfinished is larger than 0, we know that we do not have a valid sliding window yet. When unfinished is 0, we know our window is now valid. Now, the next thing we do is we try to move the right pointer if we can. So in order to move the right pointer, the conditions are, first, we'll check the O letter that we're trying to get rid of. Let's call it P. P would be this O letter that we're trying to get rid of. Okay? C is this new letter that we're adding. This is right. Well, the index of this is right, and the index is going to be left. So we're going to slide right towards the right, okay? And where we can, we're going to slide left as well. So we say P equals S previous 0, okay? And then we do while current P larger than freaks of P. Okay, this is if P, which is the character on the left hand side of our window, is overcapped. That means we can move it. What we want to do is we want to say prev.popleft current P minus equals to 1. Okay, we're going to decrease the occurrence of P in current, and then we're going to say P equals to S pref 0. So what we've basically done is we're saying, okay, if this is overcapped, right? We go back to this picture over here. If we're overcapped on this, let's say there's only one B here, right? And we're overcapped on B. We're saying we don't need more B's. So what we're going to do is we're going to say, okay, we're going to slide this to the next thing. Okay? Because I use this pref, and pref only appends letters or indexes that correspond to letters that appears in T, the next value of left pref is actually going to be C. And this becomes a new left. So once again, what we're doing here, we're saying, well, we're going to decrease since P is overcapped, right? The leftmost character is overcapped. We're going to decrease it by 1. And then we're gonna send left to the next occurrence of left. We're gonna send left to the next index where we have something that occurs in T. So notice how every time we see something appear in T, we append it to left. Okay, so that's what we're doing here. And when we pop left, when we do this pop left, we actually move the index. Next, we check if done. If not, unfinished. Well, if not unfinished, it means that we have a valid window. So now we check. Now we check if our new score is better than what we've seen so far. So our new score is basically I plus 1 minus left 0. Not I. It should be right plus 1. Right plus 1 minus left 0. If this is less than best 1 minus best 0, then best equals to left 0, right plus 1. And once we're done here, we can just return best. Well, actually no, that's not what we want. We don't want to return. So best is just the index, right? It's just the best is going to be the index, like 0 to 10 or whatever. So we want to turn this into a string. So to do that, we say as, we use a string notation in Python, colon, best of 1. Yeah. And there's one more thing we need to do, which is if best 1 equals infinity, which is we have never touched best at all, then return the empty string. Okay, so this should work. Okay, let's run this real quick. You can see that it works for test cases. Let's submit it and see what happens. Okay, and you can see that this works. It beats 75% of users was off average as far as runtime go. Okay, so that's it for today's problem. Minimum window substring. We've learned about how to use 2 pointers to simulate a sliding window. This technique is really useful for a whole bunch of other problems that you're probably going to see in future contests as well as in your tech interviews. I hope this was helpful to you. As usual, if you like my content, please throw me a like and subscribe. It's going to help you get notified when I post news videos as well. Thank you very much and see you next time.